Hi there, and welcome to my channel. In this question, we are given two functions, f of x, which is ln x plus 3, and g of x, which is x to the fourth power plus 2x cubed. And we are given the graphs of these two functions, and it's shown for us in the figure above. And we are given that there are 2 points of intersections, x equals to -2 and x somewhere in a positive region, which is given to us as x equals to b, where b is greater than 0. So we need to find that b. And the question is find the area of the region enclosed by the graphs of these two functions. And so we need to find this point b first, and then we need to find this area between these two graphs. And note that this function is actually f of x, which is ln x plus 3. And this function here is g of x, which is x to the fourth power plus 2x cubed. And so what is the area that is enclosed by the two graphs? It's integral, in this case, from -a, -2 to b of the function f of x minus g of x dx. And so how do we solve this problem without knowing b? We first calculate the solution where f of x is equal to g of x. We find such b greater than 0 that gives us the answer to this equation. So, which means that we need to find b such that b greater than 0, such that ln of b plus 3 minus b to the fourth power plus 2b cubed equals 0. So we can take out our calculators and find that b. But and so let's write it here as b equals 2. But then once we found this b, we need to calculate integral as well. So we need to calculate the area will be equal to integral from -2 to b of the functions ln x plus 3 minus function g of x, x to the fourth plus 2x cubed dx. And so we'll calculate both b and then this integral. Let's pull out our calculators and do that. So let's first find the second point where f of x equals g of x. And so let's go to solver. And the equation is ln of x plus 3 minus x to the fourth power minus 2x to the third power. Let's solve this. And the initial value, we know it's about 1. So let's start with that. Let's solve it. We get 0.782, 0.782. And so next, we need to go to, again, integral, in this case, and calculate the area, the integral from -2 to that point b that we just calculated, which is 0.782 of the difference between f of x and g of x. And so the difference is ln x plus 3, close parentheses, minus x to the fourth power minus 2 x to the third power with respect to x dx. And so the answer here is 3.6035. 3.6035. And so as we just calculated, b is equal to 0.782. And the area, the integral, is equal to 3.6035. And so we can give an answer of 3.603 or 3.604. Let's move on to question B. In this question, we are given the new function h of x, which is the difference between functions f and g. So it's the distance between the graphs, which is the difference between the functions. And the question is h increasing or decreasing at x equals negative 0.5? And so to find that, so h of x is equal to f of x minus g of x. And so what we need to find is whether the derivative of x at the point x equals negative 0.5, whether it's positive, in this case, it's increasing, or negative, in this case, it's decreasing. And so let's pull out our calculators and calculate what is the derivative of h at the point negative 0.5. And so we need to find here the derivative of f of x minus g of x and evaluate it at point x equals negative 0.5. So let's do that. Let's go to mathematics and then go to derivative. Derivative with respect to x of the function ln x plus 3, close parentheses, minus x to the fourth power minus 2x to the third power. And this is evaluated at a point negative 0.5. And the answer is negative 0.599 or negative 0.6. And so as we just calculated, this derivative is equal to negative 0.599. And because this is less than 0, the vertical distance between the graphs of f and g is decreasing at x equals negative 0.5. In this question, we are given that the region is enclosed by the graphs of f and g is the base of a solid. And then cross-section of the solid taken perpendicular to the x-axis are squares. And we need to find the volume of this solid. And so let's see what those squares are. They are perpendicular to the x-axis, and so they look something like this, where this side is C and this side is C. So the area S is equal to C squared. And what is C? C is equal to the difference between the functions f of x minus g of x. And C is a function of x, of course. So then what is the volume of this solid? The volume of this solid is equal to the integral from the lower bound, which is a to b, of the function of the area S of x dx. And so in our case, it's an integral from -2 to capital letter B that we calculated before of the function f of x minus g of x squared dx. And so let's pull out our calculator and calculate this volume, this integral. And so in this part of the question, we need to calculate the integral from -2 to upper limit b of the difference between the function squared of the area dx. So let's do that. Let's go to mathematics. Let's go to the integral. And the integral from -2 to the upper limit, which was 0.782. And the function is ln of x plus 3, close parentheses, minus x to the fourth power minus 2x to the third power, close parentheses, and this has to be squared as well. And this is with respect to x. Let's calculate that. And the answer is 5.340. So 5.340, the volume of the solid. And so as we just calculated, this integral is equal to 5.340. And so this is the volume of this solid. Let's move on to part D. In this question, we are given that the vertical line in the xy plane travels from left to right along the base of the solid described in the previous part, in part C. And this vertical line is moving at a constant rate of 7 units per second. And we need to find the rate of change of the area of the cross-section above the vertical line with respect to time, when the vertical line is at position x equals -0.5. And so let's draw a little picture here. So we have this point x equals -0.5, and then the area looks like this. So the area is equal to, as we saw in part C, is equal to f of x minus g of x squared. And so we need to find the change in A with respect to time. And what we are given is we are given that this is 7 units per second. And what it is really, this movement, this change is dx over dt. So if you look at this picture, this is what the change in x is. It's moving to the right or changing x at a speed of 7 units per second. So then let's look at what dA over dt is. It is equal to dA over dx times dx over dt. And dx over dt is given to us, and dA over dx we can calculate because a is a function of x. So let's do that. We get dA over dt at moment x equals -0.5. This is equal to the derivative of a at x equals -0.5 times 7. And so let's pull out our calculators and calculate what this is equal to, what the derivative times 7 is equal to. So here we need to calculate the derivative of the area and evaluate it at the point -0.5 and multiply by the rate of change in x, which is 7. So let's do that. Let's go to mathematics, derivative with respect to x of the function, open parentheses, ln x plus 3, close parentheses, minus x to the power 4 minus 2x to the power 3, close parentheses, squared because this is area, and this is evaluated at a point negative 0.5. And then we need to not forget multiply by 7. So the answer is negative 9.2718. Negative 9.2718. And so as we just saw, this is equal to negative 9.272. And this is in square units per second. So units square over seconds. So what this means is that the area of the cross section above the line is changing at the rate of negative 9.272 square units per second. Thank you for watching. If you liked this video, please don't forget to click the like button, write me your comment below, and subscribe to my channel, where you can find more solutions to AB Calculus AB and AB Calculus BC problems. And I will see you in the next video.